Hi, this is Mr. Vandergriff, and I'm really excited to start our STEM Scopes unit. This is a new curriculum that we're piloting this year, and this is our first segment. So I wanted to explain this for 7th grade. So the first segment focuses on organisms and non-living things and how they're made of atoms. And so each segment has a mission. And so the first mission is going to be to analyze some soil samples that have been taken by a rover from a newly discovered planet. And then we want to see if there's any evidence of life and other resources. Now, the picture that you see right here is a real photo from the Curiosity rover on Mars. You can see this is 4 centimeters, so about that big. 2 little scoops that scooped up some soil samples, and then that rover had an onboard computer to analyze the data. Here's another picture of it. You can see the rover right here, and you can see how it's scooping up some soil samples. So we've really done this, and it's pretty cool. This is in 2012. We just launched in July of 2020 a new rover called Perseverance, and it's going to be about 7 months until it gets to Mars. And I'm pretty excited. It's supposed to land, I think, on February 18th. I'm really going to be waiting to see if it lands there successfully. But they want to land it right in this crater where they believe there used to be a lake millions of years ago. And so they're going to be looking for evidence of life. Now, here's an animation of the actual rover that's en route right now to Mars. Take a look at this. This is unbelievable. Again, most of these rovers are made up in Pasadena at the Jet Propulsion Laboratory here in California. They're all automated. And this one specifically has a drill on board to take not just soil samples, but core samples. Take a look at this. So that soil sample is going to be placed into this little tumbler and then brought down in here so that they can start taking soil analysis and seeing exactly what elements and atoms are in that soil sample. But here, let's see, here's the sample. So it measures the volume, seals the sample tube, images at each step, and then moves the tubes to storage. Here's what's unbelievable. Let me skip past this. This is actually more drilling. But is this it? Yeah, actually what they are planning to do is put it on a rocket, and then that rocket's going to come back to Earth with the actual samples. So when we went to the moon, we brought back moon rocks and samples, but we have never brought anything back from Mars. And so they want to bring these samples back to Earth, and that's super exciting. So in this segment 1 of STEMSCOPES, there are these lessons or units called scopes, and there are 6 of them. And each of these scopes is going to give you knowledge, and it's going to give you understanding so you can meet the mission, right? And then really focus on the anchoring phenomena, know the answer to that. So here are the 6 scopes. There's going to be competition in ecosystems, organisms and interactions in ecosystems, human dependence on natural resources, structure of matter, change in energy on the molecular level, and then heat and matter. So those are the 6, and we are going to be starting with the first one, which is competition in ecosystems. So I've just chose a picture here. I believe this is Serengeti in Africa, and you can see many different animals. But just for a moment, just jot down in your science folder, what are they competing for? Which animals are competing for which resources? So just pause the video for a moment and write down some of your thoughts on what competition is taking place in this picture. All right, so hopefully you've identified that they're competing here for the zebra, which is food, but it looks like some vultures are also trying to move in on that. So that's the kill here, and it looks like some different animals are competing for that. That's the big thing I see. But now, what I want to start off with is this anchoring phenomenon. Again, remember, phenomena is plural, that means many, and phenomenon is singular, one. So this is a phenomenon. So it is an event. You're going to be watching, this is a marathon. So I want you just, again, you're going to have your science journal in front of you, and you're going to be writing down, what do you see in this video clip? So please watch and start writing down what is happening. Hopefully you see runners. Are they going in one direction? It looks like they're going in two directions. Maybe it's a loop. Hopefully you see, I think, 1, 2, looks like 3 volunteers giving them, it looks like to be water, or maybe Gatorade or some type of fluid to hydrate them. Hopefully you should be noticing the what the weather's like that day. Looks like the ground's wet. Looks like the volunteers have some type of protection from the rain. So you can figure out a lot from this event. So hopefully you've jotted some of those things down. Now, what I want you to do is I want you to develop some questions, because science is all about developing questions. Develop some questions about the competition. So ask some questions. Develop some questions about the runner's dependence on the water during the marathon. So come up some questions for that, please. And then also develop some questions, lastly, on how does the marathon relate to what other organisms need in an environment. So again, what I want you to do right now is I'd like for you to pause the video. Please pause it and take just a couple minutes to answer those questions in your science journal. Go ahead and pause the video and do that. Alright, now that you've paused the video and hopefully you've come up with some questions, I'm going to show you a couple that I came up with. So here's a question. What natural resources do the runners need? Go ahead, say it out loud. What do they need? Yeah, they're going to need not just water, they're going to need some food or some energy bar. Maybe they ate before. Maybe they had a green smoothie before they started the race. They're going to need to breathe air. That's a natural resource they need. They're going to need space, and some of them might need shelter. Maybe some would run with an umbrella if it was sunny or they don't want to get rained on. Again, those are some natural resources that the runners would need. Here's another question. Where does the runner's energy come from? You know this one. Absolutely. That's why we eat, right? It's like, why do you put gasoline in a car? So to run the car. Why do you eat food? So that your body can break down the food and get the potential chemical energy by breaking down the chemical bonds. And through a process called cellular respiration, you get energy from your food. Here's another one. How would the water be affected if the air temperature were below freezing? What would happen to that natural resource? Yeah, the runners would go like this and they'd get a giant ice cube. It would freeze. They wouldn't be able to get the liquid water into their system to hydrate. Yeah, it would freeze. It would change phases of matter from a liquid to a solid. How about what are the runners competing for? Yeah, some runners compete for a medal, some runners for a cash prize, maybe some just because they want to challenge themselves, they want to know they're the best in their category, or just the glory of like, hey, I'm number one, or I did, or how well you did. Maybe just even finish the marathon is a big deal for some. How about this? What are some ways that other organisms compete? Think about it for a moment. I can hear that, right? They compete for food as well. They compete for water and other resources. They might compete to have an opportunity to mate, to continue their offspring, or compete for shelter, so they have a space to sleep and rest. Let's see. What natural resources do other organisms need to survive? I think we've already talked about this, but again, food and water, space, and even oxygen and air, and even minerals. I know one time we were down in the Amazon rainforest. It was called the Tambopata Research Center in Peru. And they're these big, big, big clay licks. They're like big mud cliffs. And we saw hundreds of giant macaws, like the blue and yellow and the red and green. And they were eating the clay because there's a certain mineral ornithologists believe that when the macaws eat these toxic seeds, that the minerals in the clay help neutralize that. And so they're competing for that. So they need minerals. Here is the actual anchoring phenomena driving question for this segment. 1. Do soil samples taken from a newly discovered planet provide enough evidence of life and natural resources to support future explorations of this planet? So that's the driving question. If you would please take a moment to read over that 2 or 3 times, you should have this question memorized. So this is driving all of our instruction for this segment. So go ahead and read it one more time with me, please. Do soil samples taken from a newly discovered planet provide enough evidence of life and natural resources to support future explorations of this planet? So here's the planet. Soil samples have been taken from this newly discovered planet. And is there enough evidence of life and natural resources to continue to visit this planet, to explore the planet? So basically, here's the mission briefing right here. So the mission briefing is this. You're about to begin a journey studying about the matter of living and non-living things and discovering how the knowledge can be applied to our world. Your mission will be to analyze soil samples taken by a rover on a recent discovered planet for evidence of life and other resources. You will use this analysis to persuade Congress to fund further research. As you work towards this goal, you'll be learning the following concepts. That there's really, living things are mainly just made of 6 different elements. Earth's minerals are mostly made of 8 different elements. Earth has minerals, energy, and water resources. The interaction of motion of atoms explain the properties of matter. And then lastly, thermal energy affects particle motion and physical state. Now, many investigations will be done in class over the several weeks. We're going to be doing it in Zoom class probably, unless we start to meet in person, to help you learn these concepts from firsthand experience. After completing each investigation, take time to look for examples of these concepts in your world around you. So we want the science to come home and all around you. We want you to be a lifelong scientist and think about these things. So again, basically the bottom line is, hey, Congress, we need money, we need funding for our explorations, and you've got to justify that before they're going to release more funding. All right? Let me go back here. And so after our first scope, and we complete our first scope, you're going to get a thing called a mission briefing. You're going to get this handout here with everything I've already gone over. You're then going to have the 3 samples we talked about, the soil samples, A, B, and C. And then from there, we will fill this class mission log out together. As we do each lesson or exploration, I will let you know when, after the end of each scope, we will fill this out together. So there's some missions here, there's some information here, the class mission here, and those mission that mission log is going to help you create this project so that you can go to Congress and ask for more funding and actually be successful and convince them that there is enough evidence to keep your project alive. So again, your mission, lastly, is to analyze the soil samples taken by a rover on a recently discovered planet for evidence of life and other resources. So I hope you were successful and the odds are in your favor.